Today's lesson is 2.1, dealing with perpendicularity. Let's start with the definition of perpendicular. The definition of perpendicular is any line, ray, or segments that intersect at a right angle are perpendicular. The symbol for perpendicular is an upside down T. So instead of writing out the word perpendicular every time, use the upside down T. Since we've recently been starting to talk about proofs, perpendicular will be able to be used inside of our proofs that we're going to be using. So in this example over here, you will notice that you have line P and line M, and they're intersecting at 1 and 2 being formed right there. So what it would look like in a proof would be something like P would be perpendicular to M. That would be your given statement. Out of that, you would be able to say that angle 1 is a right angle. And the reason for that proof would be definition of perpendicular. So this is what it's going to look like inside one of your proofs, and the reason for it to go from here to here is going to be definition of perpendicular. Let's use the perpendicular idea inside of examples using solving for x. Notice the picture. We have a right angle. We have angle 1 and 2. 1 is 4 times angle 2. So angle 2 is the small one. Let's call it x. That means angle 1 is 4 times that, so that's 4x. Well, great. We need to find the measure of angle 1, but for that, we need to find x. So we can say 4x plus x, set it equal to 90 because it's 90 degrees. 5x is equal to 90. So we notice that x is equal to 18. We want to plug it in to find the measure of angle 1, which is 4x. So 4 times 18 gives me the answer of 72 degrees. Example 2. Measure of angle DCQ. DCQ is 3 times as long as measure of ACQ. So ACQ we should call x. The measure of DCQ is 3x. AC is perpendicular to CD. Well, we learned if two lines are perpendicular, they form a right angle. So there's a right angle at ACD, which now we can plug in the idea from number 1 into number 2 and say 3x plus x equals to 90. So that's 4x equaling 90, x equaling 22.5, and we want to find the measure of angle QCD, which equals 3x. So 3 times the 22.5 is 67.5 degrees. Great job so far. Let's keep moving on. Next example is in a coordinate plane. You have your x-axes, you have your y-axes. You have to figure out, remembering moving x first, then y. Find the coordinates of the vertices of the rectangle. Then find the perimeter and area. All right, so we know this point down here is at 1, -2. So to get to this point, we go over 1, and we got to figure out how many we go up. Well, if we look at this example over here, we see this point went up 3 for the y, so if we went over 1 for this way for the x, and to get to that point we went up 3, so this point over here is at 1, 3. And this point down here we have to move the x this way, which is on this line, so that's -4. We got to go down this way to this y, so this point is at -4, -2. How do we find the perimeter? Perimeter is all the sides added together. So the length of this side goes from 3 to -2, so that's 5. The length for this over here is from 1 to -4, so that's 5, which means that all sides are 5, which means the perimeter is 20 units. And the area, because it looks like it's a square to me, you got side squared, which is 25 units squared. Last question has to deal with the proofs that we've been talking about. Let's look at our givens. The given is that the measure of angle 1 is 35, the measure of angle 2 is 35, and AB is perpendicular to BD. Our goal is to prove that angle CAB is congruent to angle B. All right, well, let's mark our picture up. So angle 1 is 35. Angle 2 is 55. AB is perpendicular to BD, causing a right angle right here. Well, if we add 55 and 35 and use our angle addition postulate, this would be 90 degrees also. And we've learned back from 1.4 that all right angles are congruent. So now we can start our proof. Since we want to add these two up, you have to use the interior idea. So you have to start with D is in the interior of angle CAB. Underline it because we assume it, so it's a given. And we can use our angle addition postulate and say that angle 1 plus angle 2 is going to equal angle CAB. We want to plug in that information into R. So angle 1 equals 35. Angle 2, we underline it, equals 55. Underline it. Bracket those three together using our substitution method. We can say angle CAB equals 90. And what do we know? When something equals 90, you can call it a right angle. To get the other right angle, we have to use AB was perpendicular to BD. Underline it, given. Up to reason 4, we can say that angle B is a right angle. And since both of these are right angles, we can conclude that CAB is congruent to angle B. We need to list our reasons to the proof. 1, because you see interior and you needed to do the angle addition. 2, we're plugging in the numbers into there to get 90, so that's substitution. 3, if something equals 90 and you call it right, it's definition of right angle. We went from perpendicular to right angle, which we learned today, definition of perpendicular. And if two things are right, you could say they're congruent because of all right angles are congruent. So today, from our lesson, hopefully you learned that perpendicular causes two lines to intersect, forming a right angle. So then you could set things equal to 90 like we did, or we can prove things are 90. That's the end of the lesson.